Hello students, welcome to this session. I've just solved this JEE main test 69 and I'm doing the analysis of the physics section. This paper, two questions can be regarded as tough. One is tough 16 because I think the language is not appropriate. The language is quite confusing. The way they have given the solution in the language doesn't exactly correlate to me. So two questions were tough and we had a very easy questions also. I've taken many questions to be easy because they are the direct application done in all institutes. So that as such question might not that be simple, but it should be simple for a prepared student who has done such similar questions many times. So you have this 3, 6, 9 and 12 questions are easy. 2 were tough, so we are left with 11 questions as medium. So this is a paper where the scoring should be high. Assume anyone aspiring good should have 65, greater than 65 here, and very good student should have greater than 85 in this particular paper. So this was today's paper. The first question is from Moseley's laws, and if you have not studied the Moseley's law, just check my physics revision in 5-minute series. You will be able to get the X-ray decoded in 552 series, one for spectrum, one for Moseley law. In 10 minutes you would be able to solve it. So let's start the paper. The K alpha line obtained for molybdenum, that is Z equal to 42, is 0.71 angstrom. What is the wavelength of the K alpha line of copper? Okay, so you have to just compare the wavelength. So you know this is a straight away question from X-rays, Moseley's law, which says that frequency of that alpha line, that is proportional to Z minus 1 whole square. So here you have to calculate the lambda, so it would be inverse. So what I can say, lambda of copper to lambda of molybdenum would be Z of molybdenum minus 1 upon Z of copper minus 1 whole square. So that becomes 41 upon 28 whole square. This is lambda copper times lambda molybdenum. This will become. So now what we have, 41 upon 28 whole square. That would be 41 into 41 upon 28 into 28. And this is 0.71 angstrom. So you can make out it will definitely be greater than 0.71. So it is not 0.71. And now check it how much it would be if I take this 28 upon 41. It comes out as 1 point, let's say 130. You are left with 4. And 28 fours would be what you have, 56, 112. That is 80 will be left. So it would be, I suppose it would be 3 almost. So it is almost 1.43 into 1.43 I can write into 0.71. So it is 1.4 is almost 2 square. So it is 2 into 0.71. So it is 1.4, 1.5. Closest must be 1.52 angstrom. Solve it. Next one. A flat mirror revolves at a constant angular velocity, okay, making 0.4 revolutions per second. With what velocity will a light spot move along a spherical screen with a radius of 15 meter? Okay, is at the center of curvature of the screen. Okay, so this is what we say the sphere is a screen, and let's say this is the mirror like this. Now the mirror is rotating, so let's say this is the light spot. Let's say light was initially coming like this, so it goes like this. Now when it turns by an angle theta, you know, when it turns by an angle theta, it goes by angle 2 theta. You know this property. If mirror is rotated by theta, the spot turns by 2 theta. So the distance moved would be r times 2 theta. So here what we need to remember, with what velocity. So what we can say, the distance moved by light spot is equals to r times 2 theta. That is the relation. So if I differentiate it, the differentiation of this would be the speed of the light spot. That would be equal to 2r d theta by dt, which is 2r omega, and r is what you given 15 omega. 0.4 revolutions mean it would be 2 pi radian per second. So now what we have, 30 into 0.4 into 2 pi, that is 0.8 pi. 30 into 0.8, 3 8 is 24 pi, and pi is 3.14, so it would be greater than 72. So out of the available option we have only 175.4. So it's a good question based on the fact that if you turn the mirror by theta, the reflected ray turns by angle 2 theta in the same sense. Next one. Copper wire, 3 mm square area, carries 5 ampere current. The magnitude of the drift velocity will be, okay. So simply you are given the mass, you are given this, and you are given one free electron is contributed. So it's in a standard profile. You know I is equal to NEAVD. Now what is N? N is number of free electrons per unit volume. That here would be equal to number of atoms per unit volume into number of free electron per atom. That is what you can write. Now number of atoms. So what we have this molar mass is given and density is given. So density gives you the mass. So the moles per atom would be that density upon the molar mass. That would be in moles per volume, and that would be multiplied by Na. That will give you number of atoms per unit volume, and 1 electron is given. So this is small n. So this is small n. Now what I have, you need to calculate Vd. Vd, what we know is I upon NEA. Put the value of n. What you will get? You will get now I into molar mass upon rho EA into Avogadro number. So now it would be a calculative thing. I is given as 5, molar mass is, if I convert, yes, it is 63.5 kilogram. I doubt. Copper mass 63.5 kilogram per mole. I haven't seen such a data. So let's assume it. If they are taking it, I can't help. It should be gram per mole. Let's do what they have given. And then let's finally check whether the answer comes or not. 8920 is that this 1.6 into 10 to the power minus 19. A is 3 into 10 to the power minus 6, and Na is 6 into 10 to the power 23 I can take. So 19 and 6, 25, 23 and 1, 24. So it would be 10 to the power minus 1 to 10 goes up. So 5 into 6, 3, 5 as per your this thing, this 0 we have taken. 1.663 is 18. That is what we are getting. Now what we are left with now, this is 635, 892, 1.618. So if I do this approximations, let's say first of all order I want to know. So 635 into 5, so 600 into 5 is 3000, 3000 plus 35 into 5, that is 3175. And here what you will have, 892 into 18, so roughly what you will have, 900 into 18 approx, or what you can have 18 nines is 162. So 16,000 it would be. 16,000 into 1.6, that would be around, let's say 25,000 something. So it would be 1 by 10th order. So 2.4 would be the answer for sure. Now do the exact calculation. If I do this exact calculation, so you can do let's say, why should I take calculator? I should try myself. So 18 into 1.6, if it is cancelling up, and doesn't seems to be cancelling with anything, no issues. Let's try it. 18 into 1.6, so what we have, 16 8s are, we have 128, 16 ones are 16 and 12, 28, so it would be 28.8. so I'll do with my style 3175. I roughly take it as 900 into 28 to simplify, because options are far away. We can do such a calculation approximation. And what we have, 28 9s are 9 8s are 2, 9 2s are 18 and 7 25, 2520, 3175, 25200, sorry. So now what we are left with, this would be 0.31750, it would be 1 for sure, and it would be, let's say, 0.1314 what I am getting. So 0.1 I can go for 0.12 meter per second from the calculation. If you don't trust yourself, do the complete calculation. I go by my way. So I am sure it is 0.12. Let me check if the answer is this. Where's the answer? I can see in the app. Yes, 0.12. Okay, so we have done it. Next, neutral sphere, radius r, density rho, intended to be suspended with an electric field E existing on the Earth's surface directed vertically up. What fraction of the electron should be removed from the sphere, given that the atomic number, and this assume that it is hold to the necessary charge without any leakage. So simply what you have to balance it. So mg must be equals to qe, and field is up, electrons are removed, so positive charge, so it would be upwards. So the q required is mg by e, and q, what you know, is equals to ne. N is the number of electrons you need to take out. So the number of electrons to be taken out is mg upon e. Now we have to find the fraction, so we need to find out what is the total number of electrons initially in it. So total number of electrons initially in it, what would be equal to, first of all, that is equal to total number of protons. Now what is the total number of protons? First of all, what we can find out, but first of all I need to find out the number of moles. So number of moles would be mass upon molar mass, that we write. Now mass is density into 4 by 3 pi r cube, and this molar mass. This molar mass I can write it as A, because it would be around A only, because that is the mass number that you write. So this will give you the total number of moles. This is moles, sorry. So moles I should write, don't confuse it. Total moles is like this. Now, so the number of atoms we will have is rho into 4 by 3 pi r cube upon A into Na, and the number of protons or number of electrons, that is the capital N that we were searching for, that would be equal to rho into 4 by 3 pi r cube Na A into Z, because each atom has Z1. So what we have, this n by n, this n by n would be m. Okay, I can write this m only. Why I have written it, it would be easy, let it be m only, so it will cancel out. So m and m cancels out, it becomes G upon E, and here it becomes NaZ upon capital A. So what it becomes, G times A upon what I am getting, EENAZ. So what is the option that is looking out closest to it? So I am getting option C here. Okay, next one. Two identical satellites are moving around the Earth in circular orbits of height 3r. Height is measured from surface, where r is the radius. The ratio of their kinetic energy is, we know kinetic energy is G mm upon 2r. R I can write as r plus h in that case. So what I will have, k1 upon k2 would be the inverse. So for the second one, what we have, r plus r. For the first one, we have r plus 3r. So this comes out as 2 by 4 means 1 by 2. So we'll go for option B. Definitely the one which is closer will have more kinetic energy. Next one. An ideal gas is compressed to half of its initial volume by means of several processes. Which of the processes results in the maximum work done? So you remember, when it is compressed, it is something like this. Isobarically it would be like this, V0 to V0 by 2. Let's say at P0. This is PV. Isothermally it goes like this, and adiabatically it goes like this, because the slope is more, the more pressure change happens. So the maximum work, the magnitude of the maximum work will be in the adiabatic process. You can check, the maximum area will be done by the adiabatic one. Okay, you cannot change volume isochorically, so option B was just to fill up the options. Next one. A conductor AB of length L carrying current I is placed perpendicular to a long straight conductor XY carrying current I. The force on AB will be, again this is a standard profile. Just go at a distance x and take a small strip of length dx. The force on it dF would be bi dl. B is what, mu naught I upon 2 pi x into what we have, this length is b, I is I, and L is dx. And the direction of force, you so see the magnetic field is this. So if I do L cross B, it would be upwards. So the net force would be upwards, and it would be given by mu naught I square by 2 pi. I can take common, dx by x. Limit goes from L by 2 to 3L by 2. So what we'll have, mu naught I square upon 2 pi, or II, whatever we can write, I have taken to be same. So if it is different, it is I into I. So that you can make it out. And this, if you solve it, would be ln x, so it would be ln 3. So as per the option, it should be this one. Option B is the most appropriate one. Next. A ball is projected from the ground at an angle theta with the horizontal. After 1 second, it is at 45 degree with horizontal. After 2 seconds, it is moving horizontally. After 2 seconds moving horizontally means this is the highest point. Highest point means this is t by 2, or you can say time period is 4 seconds. Time of flight is 4 seconds. So what is the velocity of the projection? And after 1 second, it is moving at 45 degree. First of all, time period is 2 uy by g. So from here, uy comes out as 40 by 220. That is 20 meter per second. So after 1 second, vy would be uy minus g into 1. That would be 20 minus 10, 10. And 45 degree angle at that moment means 1045 would be vy by vx, and vx is always ux. 1045 is 1, that means that is equal to ux. So the initial velocity would be ux square plus uy square, 10 square plus 20 square. That is, you can write as 10 root 5. So just remember what it was saying, after 1 second. So after 1 second, this angle is 45. So it means this vy is equal to this vx. Vx was ux and vy was uy minus gt I used. Okay, next one. A 2000 kg rocket in free space expels half a kg of gas per second at exhaust velocity. The increase in the speed of the rocket in this time is, okay, in this time is. So first of all, what we have, we can directly say the thrust force is equal to, this is dm by dt into v relative, with which was ejecting it out. So the thrust force is fixed, that is 0.5 into 400, that is 200 Newton. So this 200 Newton force is acting continuously for 5 seconds, and the mass in 5 second loss is very, very small. So I can directly write this ft into t would be equals to change in momentum, that is m into v. So v would be ft into t, that is 200 into 5 upon mass, which is 2000. So it comes out as half meter per second. So the speed gain would be 0.5 meter per second. Next. If mp denotes mass of proton, mn denotes of a neutron, a given nucleus a given nucleus of binding energy B contains Z and N protons, mass and Z of the nucleus is given by, okay, so what we know binding energy, you definitely know binding energy is simply equals to the change in mass. We know the original constituent mass is more, so Z times protonic mass plus A minus Z times neutronic mass minus mass of the nucleus that we write, the nucleus mass is given, yes, into M into C square, that is what we write. So from here what I can make out, M would be equal to B by C square, that would be, if I take it, it would be negative plus ZMP plus A minus ZMN. So now going by this, what we are left with, only one choice, which is option C, so you can go for it. Next one, two identical springs are connected to two light rods in parallel combination, and then a third spring is connected, and in combination to the series, the combined system is fixed to the ceiling block of mass M is attached as shown, is slightly displaced, so you need to find out simply K equivalent. So these two are in parallel, that becomes 2K. So now you have K and this 2K in series. So in series what we write, K equivalent would be inverse, so directly K into 2K upon K plus 2K, that is 3K. So it becomes 2K by 3. So time period, you could directly write 2 pi root M by K equivalent, which is 2K by 3M, so that would be 2K by 3, so that would be 3M by 2K. So going by the option, it should be option B, simply spring equivalent you need to find out. Standard profile of SHM. Next, for a certain metal, incident frequency is 5 times threshold frequency and maximum velocity of the photoelectron is this. If the incident frequency is 2 nu0, the maximum velocity will be, just remember, for the first case, K1 max would be h times 5 nu0 minus h nu0, that is 4h nu0. For the second case, what you are given, it is double, so h times 2 nu0 minus h nu0, that is h nu0. I can directly say that is K1 max by 4. So if kinetic energy is 1/4, you can say kinetic energy is proportional to V square, so V square will become half, so V will become half, V will become half, that will become 4 into 10 to the power 6. No need to go for numerical calculation. Next one, the radius R of a soap bubble is doubled after under isothermal condition. If T be the surface tension, the work done in doing so is, so it is doubled, so work done, what we can say, is equal to S into delta A. So here double area you need to do S is T, and delta A would be not 4 pi r square, it is a, what we can say, it is a change 8 pi r square, so it would be 8 pi into double radius 2r whole square minus 8 pi into r square, so it becomes 32 minus 8, 24 pi r square T, option B, because double surface is formed in the bubble. Next, from a disk of radius r, a concentric circular portion of small r is cut out, leaving an annular disk of mass m. The mi of this about the axis perpendicular to its plane and passing through its center of gravity is, okay, about the axis of the annular disk about the axis and passing through its center of gravity. So here, since it is concentric, so the center of gravity remains same, that is like this. This is the annular disk. So now it's in standard profile. First of all, this M is the annular disk mass. So first of all, I can say what is the mass of the cut section. The mass of the cut section to the mass of the remaining section would be equal to A cut upon A remaining. So A cut is pi r square, A remaining is pi r square minus r square. And this is given as capital M, so cut section has a mass equal to M r square upon r square minus r square. So what we can say, that total Mi of the complete section would be total mass, which is M plus M cut, which would be mr square upon r square minus r square into r square by 2, that is for sure. Now what is the of the cut section? Cut section itself is a disk symmetry, so because of that it will be mr square by 2, its mass is mr square upon r square minus r square into its radius r square by 2. So the remaining one would be, the required one you can say, is difference of these two. So if I do the difference of these two, what I will get, take M as common, and if I simplify this inside, it will become r square upon r square minus r square into r square by 2. Let it be like this, let this bracket be like this, minus it would be r4 upon r square minus r square, and here 2 I should also take common. So what we have, M by 2, and I take r square minus r square also as common, it becomes r to the power 4 minus r to the power 4 will become r square plus r square into r square minus r square, that will cancel out, that will become r square plus r square by 2, and generally people advise to remember this result directly also. I have not used a direct result, I have derived it for you, but many in the many institutes it is directly being taught, I think. Next one. A transistor oscillator, okay, is an amplifier with positive feedback. Yes, it has an amplifier. It is an amplifier with reduced gain. No. The one in which DC supply energy is converted into AC output energy. Yes, the DC batteries are used to generate an AC signal. So the first one is right and the third one is right. So option C is right. Next one. We had a positive feedback here. You remember that? A cylinder closed at both ends is separated into two equal parts by piston impermeable to heat. That means adiabatic. Both the parts contain same masses of gas at 300 and 1 atm. Now the gas in one of the part is heated such the gas shifts by 5 centimeter. Then the temperature and pressure of the gas in this part after heating will be, okay, so it shifts by 5. Now what we have, because for the second one what we can say, second one the compression will be adiabatic. For the first one you have, let's say, heated it. So what we will have now, so we can directly go for the gas in one of the part is heated, plus we have a piston. Here the information I feel is not given appropriately, and it was tough to calculate. And what if I'm seeing the solution they have taken an assumption which should be written in the question, which is actually written in such questions. You find the similar ones. Let's say this was in between, this was 45 centimeter, this was 45 centimeter. Now initially what we had, both had 300 and both had 1 atm. Now because you are compressing it, no heat is flowing, so because this would be adiabatic also, so its temperature should also change, and if that change, it would be tough to calculate now. But they have assumed, the question assumes that this part's temperature is maintained. This line should be written, which is generally written in such question. So if I assume this temperature is maintained, now I can solve for. So now the second one has expanded, so it would be like this. This would be 50 and this would be 40. Again I will know whatever be the pressure, it would be same. Let's say PP, this is 300 Kelvin, I have to find this temperature. So now what I can do is say, I'll say the moles will remain same, so the PV by RT ratio will remain same. So I can, for the first part, what I can write, the initial pressure was 1 atm, the volume was area into 45 centimeter divided by RT. R was R and T was 300, would be equals to final pressure P into A into 50 upon R into T. So this AR goes, so what we have, this ratio P by T, from here I can get it as 45 upon 300 into 50. This is the first one. Now similarly for the second one, what I can write, 1 atm into A into 45 PV upon NR, that is R into 300. Again the same equation, this would be again P into what we have, A into 40, and here the temperature still remains 300. So this goes. So what we have, A goes. So the pressure comes out as 45 by 40. You write it as 9 by 8 atm. So if you write it 9 by 8 atm, the temperature here now becomes 300 into 50 upon 45 into what we have, 9 by 8. So 9 is 5, 50 is 10. So that is 3000 by 8. So 3000 by 8, if you do this comes out as 3, 24. 60 would be 7, and then 4, that is 375 Kelvin. So it is 375 Kelvin and it would be 1.125 atm. So I think question language is not appropriate. It's tough to make out from this language without assuming this thing. Next, the dimensional formula for aerial velocity. Aerial velocity is rate of coverage of area, that is area upon time, that is meter square upon second, that is L2T minus 1. So L2T minus 1, where it is option C, you can make out. Next one. Consider two Polaroids A and B. As shown, unpolarized light is incident on A. Now both are rotated simultaneously by 180 degree in the same sense of rotation, such that every instant their axis always remains parallel. During the rotation, intensity of the transmitted light through Polaroid B will remain same, because their angle is still the same, their axes are always parallel, so there won't be any change. If only one was rotated or there was not, then the changes would have been seen. The instantaneous displacement of a SHM particle oscillator is this: its speed will be maximum at a time. So speed will be maximum, you know, when the displacement is 0. So displacement 0 means this term should become pi by 2 for first time, because it is starting from pi by 4. So omega t should be equals to pi by 4. So t should be equals to pi by 4 omega. So it's an easy one if you can make out. This is 19th. Next, the last SOT. If W1, W2 represent the work done moving 3 different paths in the gravitational field. We know it is a conservative field, so A to B, you go by any path, work will remain same. This is the easiest of the question you can get. Okay, now go for the subjective numericals one. Now what we see: machine gun has a mass 5 kg, fires 50 gram bullet, 300 bullets per minute at speed of 400. The magnitude of force required, you directly say F is what? dp by dt. That would be equal to n times mass of bullet into velocity of bullet, because each bullet gets momentum mv in 1 second. How many bullets you have fired? N is number of bullets per second. You have 30 bullets per minute, that is 30 by 60 bullets per second, into each bullet mass is 50 into 10 to the power minus 3 into 400. So now what you get, this is 1 by 2, and 1 2 3 it goes, 5 4s are 20, so it is 10 Newton forces required to hold it. So 10 you will write, not the Newton, only simply 10 you have to write here. Next one, an AC voltage applied to an LR series circuit inductance is the value of maximum current. So simply find out Z. Z would be XL square plus R square. XL is what? 1000. Okay, it is 1000 into 3 millihenry. So this is 3 ohms. So 3 square plus 4 square, Z is 5 ohms. So I max would be V max by Z. So it's an easy one for you, 5 by 5. This is one of the easier one, I think, from the AC chapter you can get. Next one. Next you have 23rd. What it says: particle moves according to the law x is r cos pi t by 2. Okay, the distance covered from 0 to 3 seconds is nr. So first of all, what you can make out, r cos pi t by 2, this is the x coordinate that you are getting. Okay, t equal to 0. At t equal to 0, if I check, x would be equal to r cos 0, that is it is equal to plus r. And at 1 second if I take, it would be at 0. At 2 seconds if I take, it would be pi, that it is x equal to minus r. And at 3 seconds if I check, again it would be at 0. So if, because it is a cos like function, I can make it out. Initially it starts from 0, so it is at plus r, then it decreases to 0 in 90 degree, then goes to minus r, and then again goes to 0. This is the path. So this is r, this is r, this is r. Total distance would be 3r. So it's an easy one. You can do by any way. I have done by my way. You can do by your way. Okay, so not a tough one for you. Next one. Uniform copper rod 50 centimeter insulated on the side and has its ends exposed to ice and steam. So that is 100 and 0. You can say if a layer of water 1 mm thick at each end, the temperature gradient in the bar is that the thermal conductivity, assume it to be this, and water is this. So now what you have some water layer 1 mm thick at each end. So you have 1 mm thick at each end, and now you need to find out that particular thing. So how you are going to, let me represent like this. This is the rod, and we have this water layer like this. So whatever it is in series. So I can say both heat transfer will be same. This is 100, and what we have, this is equal to 0 degree here. I don't know what is the temperature at those junctions. It's tough to make. Let's say it would be theta 1, let's say it would be theta 2. So what I can say, the heat flow rate through this H you know is equal to Ka delta T by L. So here we have K of water, delta T is what we have, Ka delta T. So area A delta T is 100 minus theta 1 upon L. What is L here? 1 mm. That would be equal to K of copper into the temperature change. A into temperature change would be theta 1 minus theta 2 would be the drop, divided by, we have 50 centimeters. So doing by this, what we need to find out, we want to find out the exact values we need to remember. So let's first of all try to find out this differences. We just find this theta 1 and we might get some clue. Let's see. So K of water is 0.4, area get cancelled. So 100 minus theta 1, I should write it as 0.1 centimeter, so no need to conversion. Then 50, copper is 400, theta 1 minus theta 2, that is what I am getting here. Okay, so this is the way we will get. So what we will get now, this is 4 into 5, and let's say cancel it, this is 8. So 4 8, that would be 200 minus theta 1 is 2 times of theta 1 minus theta 2. That means this drop, whatever we have getting, and this drop is a double of this drop. So let's say this drop is x, so it is double, sorry, so it is 2x, this is x, this will again be 2x. So total drop is 5x is equal to 100, that means x is equal to 20. So the change over temperature of the rod is 20, so I can directly calculate from this copper one, 400 into what we need to know, area, what we need to remember, okay, temperature gradient only. So we have to find out temperature drop is 20, so temperature gradient is 20 upon 50 centimeter. So 20 upon 0.5, that is 40. So it's a nice question, asked very smartly, not tough, but it is asked very smartly. So we have done now. Next one. The distance between the virtual image from its real object is 60 centimeter in case of a concave mirror, and the image formed is 3 times magnified. Virtual image magnified, that means the object is placed between pole and focus. What is the magnitude of the focal length? So what we can say, magnitude is 3, m is 3, and that is equal to what we have, minus v by u. So here both will be on opposite sign. So what we can say, the mod v upon mod u comes out as 3, and gap between them will also be like this, that is equal to 60. So going by this, mod v is 3 times u, so 4 times mod u is 60, so mod u comes out as 15. So u is minus 15, v would be equals to 45. Now you can calculate the magnitude of focal length easily. 1 upon v, 1 upon 45, minus 1 plus 1 upon u, sorry, 1 upon minus 15 is 1 by f. So 1 by f comes out as 45. It would be minus 2, so f comes out as minus 22.5 centimeter for sure. So that's again a good question, not tough but a smart one. So this was the today's paper. Thanks for watching. Keep sharing the channel, keep pouring in your comments. Thank you once again.